Okay, so in our notes, this is starting section 2.7, which is covering equations and inequalities involving absolute. Let's talk about some background information that you should have remembered from pre-algebra or algebra. Earlier in the year, we did work with a couple of absolute value problems, but it was just working with numbers in general. What do you guys remember about the term absolute value and what it means when in relation to like a number line? Yes, sir. Perfect. Hayden said it. So fill this in. It's the distance between the number and 0. Now, in this class, you're going to hear me refer a lot to the word units. I'm going to say units instead of an actual number. So, for example, if I give you the absolute value of 4, okay, or the absolute value of -4, both the answers to these two right here is going to equal to a positive version, okay, because this is saying 4 units away from 0, and even though this is -4, when we take the absolute value bars away and we translate it mathematically, it's still positive 4 units, or 4 units away. So what that would look like on the graph is 4 units in the positive direction, 4 units in the negative direction. Okay, so just keep that in mind. When I talk about units, I'm referring to using the number line. Okay. Additional information, just absolute values indicated with these bars. A lot of the stuff that I've done is handwritten, so please don't confuse that with the number 1. Typically, I try to extend them farther than the number. But with any absolute value signs, you always have a beginning and an end. So try not to let that confuse you if that's a 1 or not. Most likely it's going to be a starting and an ending point, and then what's in between the bars is what we'll be working with. Okay? Now, what's unique about absolute value? One thing that we can keep consistent is our solution, our answer. If you're working with just a number, whether it be positive or negative, will always be what? What are these two values? They're always positive. Okay, so that's something to keep in mind, that the absolute value of any number is going to be positive. Now, that's a pretty easy concept to remember. We're going to start to introduce those variables, which is going to change this theory. It's not changing it so much, but it's going to be changing the process of how we solve for it. It's not just going to be changing the numbers inside, but we're going to be working, and I'm going to show you some techniques to actually solve for x when it's inside the bars. Okay. So if you go over to page 2, these are just some properties of absolute values that you guys have either already covered in pre-algebra or regular algebra, and just some things to think about. Imagine A, that's not a 9, that's an A, as any real number, okay? Regardless of the value of A, whether it's positive or negative, the answer is always going to be greater than or equal to 0. It's always going to be a positive term, okay, like we said on the last page. Some more principles or properties. This right here represents a multiplication sign. If you'll just make note on your notes so that you don't assume that that's a variable x. What this is saying that is if we have two real numbers, a and b, and we multiply them together, regardless if they're positive or negative, if they're inside the absolute value bars, it would be the same thing as saying the absolute value of A times the absolute value of B. These are the same thing, so you can kind of rearrange and work with your real numbers depending on the situation that you have. Now these two we probably won't see a lot in the class. This last one is where we're going to start adapting to putting variables in our absolute value. So make a note that this U is representing a variable. Now, your variable can be any letter. It can be X, it can be Y, it can be S, T, it can be any symbol pretty much. So the absolute value of any variable, okay, and it's going to be equal to some real number, is the same as taking the absolute value bars away and setting that variable equal to the positive and negative version of your real number. Okay, this right here represents a real number. Okay, so let's try to apply that to solving an actual equation when we have a variable. Okay, this is the first one is very, very simple. It says solve for x when you have the absolute value of x equals 6. So one thing that we can take from this property that we looked at above is that this can be rewritten without the bars as x is equal to the positive version of 6 and x is equal to the negative version of 6. With all of your absolute value equations, you're going to have, unless we're talking about a special case, 2 solutions. Okay? The confusing part is that typically we are not having to deal with absolute values. So we've got to think of what values inside the absolute value would give me a positive 6. Well, 6 or negative 6. Okay? Now, you won't be graphing equations. I just put the number line on here to remind you that it's 6 units away from 0 this way. That's where you get the positive version. And it's 6 units in the negative direction. Okay? Last thing for this page, how would I write my 2 solutions? Remember, for equations, we use bracket notation, right? Since there's 2 solutions here, we are going to put it in numerical order. We're going to open our bracket first. Negative 6, we're going to separate those with a comma. Positive 6, close brackets. Now, one of the mistakes that students make in this section is they assume that the answers are always going to be the same, but a positive and negative version. That's not always true when you're dealing with absolute. For this type of problem, when x is the only thing inside your absolute value bars, yeah, it's the positive and negative version. But when we start introducing numerical factors in there, you may not have the same 2 values. Okay? So let's go on to the next page. Now, these next 2 examples, we're going to use the same theory that we just got done with the x and negative, or x and positive and negative 6. However, if you'll notice that what's different about this type of equation, it's not just a single variable, right? Inside the absolute value, there's an additional numerical factor. So you kind of have to think of this in just a little bit different than literally just substituting positive and negative versions. What we're trying to say is the values of m minus 3, what values for m can we put into that equation that would give me 4? Okay? So what we're trying to do is we want to set m minus 3 equal to the positive version of 4 as well as the negative version of 4. Because essentially if this is what's equal to either 4 or negative 4, the absolute value of that will give me the positive version. So here you're going to write 2 equations. Okay? You're going to take the absolute value bars away. You're going to write one version equal to the positive version of 4. You're going to write the second equation equal to the negative version of 4. The key thing is do not change the sign inside the absolute value. You want to keep that entire expression the same. The only thing you're changing is the number outside. Okay? And then you're just going to solve straight down at this point. Okay? How would I solve for m on this left side equation if it were by itself? How do you get m by itself? Add 3 to both sides, right? What's easy about this is typically what you do to this left side, you're going to be doing to the right one as well. Okay, and so what does my m equal? Well, 4 plus 3 is 7. The second part, negative 4 plus 3 is negative 1. So here I've got two solutions. You will write your answer in bracket notation. Make sure that it's numerically in order. So even though we solved for negative 1 on the right side over here, we do want to put that first in our bracket notation. Now I'm not going to do this on every single problem, but I do want to show how that you can hand check your answers, because remember, on portions of this class you can't use a calculator. So let's double check to see if we even have the right answers for these. Okay, let's do the 7 first. What you're going to do is plug this m equals 7 back into the original equation. So 7 minus 3 in the absolute values equals positive 4. And what you're going to do is simplify this straight down. What is 7 minus 3? 4, right? Okay. Does the absolute value of 4 equal positive 4? Is that a true statement? Yeah. So that one's good. Let's do the same thing for negative 1. I'm going to plug negative 1 into my original equation and then simplify it straight down. What is negative 1 minus 3? Negative 4. Does the absolute value of negative 4 equal positive 4? Is that a true statement? Yeah. So if you get the answers to both of those correctly and those match your solution, then you know that you've hand checked it correctly. You have the right answers. Okay. Now I'm not going to hand check those all the time, but I do want to show you at least one example so you can have a resource for your quiz and test to be able to check without having your calculator. Okay, so what I want you to do is I want you to solve example number 3 on your own. If you'll notice, the format of these is identical. We've just changed numbers. Same thing is you have a coefficient in front of your x term. When you write your two equations, solve it as if it were an equation by itself.